What is up, mathletes? Welcome back to the episode of Math with Dr. Math. And today we're going to look at why a to the 0 equals 1. Don't go anywhere. Alright, so let's dive into this problem here. And we have a lot of mathematical properties that we use, and people are like, why does it work? They're like, why? I want to know. And here's the reason. All right, so let's go back to some facts that we just know. And this is what I love about math, how we could use some facts that we already know, and we could become creative in how we rewrite them to help us prove statements just like this. All right, so what we know is some number divided by itself, right? As long as it's not 0. Any number divided by itself, as long as they're not 0, is equal to 1. We all know that. All right, so if we kind of look harder, right, we're going to be a little bit more creative here. What I'm going to do is I'm going to rewrite this, and I'm really going to write down the same exact thing, but the only thing I'm going to attach here visibly so you could see is that these have exponents, right? So whenever you write down a really has an exponent of 1. All right, so in reality, I haven't changed anything. All I did is I wrote the 1 here, right? But even if I don't write the 1, there's a 1 that exists as the exponent, all right? So 1 and 1. So I still get an answer of 1. All right, why do I use this? Well, we have some nice exponent rules that we could use, and there's a few ways we could work this, all right? One of our exponent rules says that if we were to subtract these exponents, right, when we divide, these same bases, notice they both have the same base of a, if we were to use our exponent rules, here's what it says. If these have the same base, this is equal to the exponent of the numerator, which is this one right here. Let me write it in blue here. The top exponent minus the bottom exponent, minus that bottom exponent. And that gives me, right, if I subtract those two exponents, that gives me a to the power of 0. But notice, this right here is equal to this right here, which is the same thing as a to the power of 0, because all I did is I subtracted 1 minus 1, which gave me 0. But we already knew that a to the first power divided by a to the first power is 1. So that means that this right here has to be equal to 1. So that's one route that we could take, right, using our rules of exponents. Another way we could look at this, right, using this right here is, so this is option 1. There's so many different ways we could go to prove this statement. Or we could have also said a to the first power, right? So I have a to the first power, but remember, when you divide by this right here, we also know that this is the same exact thing as multiplying, so I'll put a little dot there, right? Multiplying by a to the negative first power. Because whenever I have a base that's in the denominator, I can move it up to the top. But when I move it up to the top, remember what the properties tell you. The properties tell you that this exponent is now going to change signs. So you really have to understand your rules of exponents, or this won't make sense. And since I'm multiplying these and they have the same base, what that tells me, right, by my rules of exponents, is that all I do is add those exponents, right? So the rules say I add the exponents, so I get negative 1 plus 1, which leaves me with a to the 0 power. And once again, we already know that all this was equal to 1. So regardless of how you go, regardless of which way you want to go here, if you use your rules of exponents properly, we have shown that a to the power of 0 is equal to 1. And we've shown it 2 ways here. So again, these properties, that's great that you're asking these questions of why do these work? And you could see we being very creative, not only can we come up with properties like this, but we could do so much more. Anyways, hopefully that was interesting. Hopefully that helped you out. And again, don't forget to like, subscribe, and tell a friend for 10,000 of the great things we're doing here in Dr. Math Studios. Peace.